Here's a quick follow-up, because I forgot to mention this last time. It is possible to substitute an amine by adding something onto the nitrogen. So, for example, here we have a triply substituted amine. We've replaced all of the hydrogens on ammonia with alkane chains. So what you do in that case is you just go ahead and choose the primary chain. Okay, that would be the longest chain, or the chain that gets priority. It might be a ring, what have you. So that would give you, this 1, 2, 3. So we're going to have a propane chain as the main chain. And these two would be treated just like any other side chains, except that they're on the nitrogen instead of on one of the carbons of the main chain. So here we have 1, 2, so this is an ethyl, and just 1, so this is a methyl. Okay, just like normal. Now, the difference is that because they're on the nitrogen, you can't say where they are just by putting a number on there. You have to say that it's on the nitrogen. So this would be in ethyl, in methyl, propane, 1 amine. Okay. So instead of numbers, 1, 2, 3, or what have you, you just use the letter N. And that is how you indicate that your side chains are bound to the nitrogen of the amine group instead of one of the carbons on the main chain. Now, if you have multiple amines, okay, that's not even a problem. Okay. So, in some ways this is a nice simple chain, in some ways it's a little complicated. So, what we have here is a methyl, ethyl, methyl, and prop-2-il. And then this chain is 1, 2, 3, 4, 5, 6, 7, 8 carbons long. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's either 3, 6 or 3, 6. So that means that our numbering is going to be quite complicated. I'm pleased and surprised that this is the case. I was doing this kind of at random. So we put our side chains in alphabetical order, just like normal. So ethyl, dimethyl, because we have 2 of them, one down here and one up here, and prop-2-il. Okay. So left to right versus right to left. Now, the way you number it when you have multiple nitrogens, things bound to different nitrogens, okay, going left to right, you have in 3 versus in 6. In 3 is down there, in 6 is over there. Versus right to left, in 3 versus in 6, it reverses. Now in 3 is the one over there versus in 6 being the one over here. Okay. So, once again, we look at where the differences are. Our ethyl group left to right is on in 3 versus in 6. So now we have our first difference. N3 is lower than N6. We can go ahead and stop there. Our dimethyl are N3, N6, and our prop-2-il is N6. So you indicate where on the main chain the nitrogen is using a superscript. And that tells you that the carbon it's bound to is that number. All right, so that makes this N3 ethyl dash N3 comma comma N6 dimethyl dash N6 prop 2-ill octane. Not amine. Octane dash 3,6-diamine. Okay. So it's getting fairly complicated here. Now, because you can have up to 3 things, I should say, bound to any one nitrogen, this is one of the more complex possibilities you'll encounter without, going into the complexities of rings. For the most part, I'll try to avoid anything even as complex as this. This one is relatively simple, as you can see, 4 different side chains on those 2 different amines. But even so, it's fairly big, kind of nasty. But it's still following the same set of rules. Okay. As for the properties of amines, you can find those back in semester 2 toward the end. I discuss the different properties of the functional groups. All right. See you when we talk about alcohols.